Okay, so now let's go to, welcome back, by the way. Let's go to number 25, and we'll try to finish up this whole practice test. Number 25 says to study which presidential candidate the California voters support. Well, it's pretty obvious. A street interview was conducted in downtown LA and in downtown San Francisco. What type of bias would you be present? Would be present? Okay, and so I hopefully you can see this immediately, right? You go to downtown LA and downtown San Francisco. Those two cities do not represent the entire state, right? Yes, they do have a lot of people, but if you're talking about these two geographical areas and just the downtown area, not even suburbs, you do have a problem. This is called selection bias, right? Sometimes it's called a geographical bias because this one has to do with geography. But the selection bias more generally means that the sample is very, the sample is chosen in a very selective way in such a way that it does not reflect the entire population. You remember the entire population here is the California voters, right? So it would be more appropriate to pick people from big cities and suburbs, as well as from the rural areas, agricultural areas, maybe the Central Valley, and maybe in other places, the mountains, and so on. So that is the problem, okay? And so you can call this the selection bias to make sure that every part of California is fairly represented. Here, clearly, it is not. Okay, number 26, find the mean, median, and the mode of this set of data. Now, the way it says it, you can tell that this is not written in any order, right? So the first thing you may want to do is to make sure that you write them in the correct order. I think if you rewrite this, you can find it's 1, 2, 2, 2, 2. You have 4 2s, right? If I remember here. Yeah, you have 4 2s, and then you have 1, 3, and then 2 4s, and 5 and 6. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have copied the 10 numbers from the smallest to the largest, okay? And this is something you have to do in order to find the median. And the mean is, of course, you have to add up all the numbers and then you divide it by 10 because that's how many numbers you have. I'm not going to do this, but if you do 1 plus 2 plus 2 plus 2 plus 2 plus 3 plus 4 plus 4 plus 5 plus 6, you get 31, okay? And so the answer, it's 3.1. That is your mean. The median is the middle value, but notice here you have 10 altogether. So you have 5 lower half and 5 upper half. The middle part should be right here, but there is no middle number. So you take the 2 middle numbers and find their mean. And so this will be 2.5, okay? The mode is the one that happens most frequently. In this case, you have 1, 2, 3, 4 2s. So the answer is 2. No problem here, right? Okay, let's go to number 27. Here you have a question about normal distribution. Suppose that the weight of a certain animal is normally distributed with a mean of 300 pounds, heavy, and a standard deviation of 15. All right, so it's 315 will be one standard deviation above the mean and so on. Find the probability that a random one of these animals weighs less than 330 pounds. 330 is over here. All right, these are the values we call X. We need to translate into z-scores in order to use that normal distribution table, sometimes called the standard normal distribution table, because z is the standard normal, what we call random variable. Right? Remember, the average always has the z-score of 0, and 15 pounds. Okay, so if you add 15 pounds, it'll be the z-score of 1. If you add the 15 twice, that would be 330, and that's the number we want. So it's actually easy to figure out that the z-score corresponding to 330 is actually 2, exactly 2, right? Because 330 is 2 standard deviations above the mean, which the mean is 300, right? So that part is easy. In other words, what we're trying to find is the probability that a random one of these animals weighs less than this. And so we can look up the percentage of data in this, right? And then don't forget, all of these animals that weigh below 300 also weighs less than 330, right? And we know exactly how many or what percent is below the halfway mark, below the mean, that's 50. So let's look up this. All you have to do is look up 2.0 or 2 in our table, right? So here, that's 2.4772, right? So what this is saying is here you have 47.72% between 300 and 330, okay? So the answer is this number plus 50%. And so the whopping 97.95% of this, whatever the species of this animal is, 97.95% of these animals weigh less than 330, okay? So that means roughly only top 3%, or not even top 3%, more like top 2.25% of the animals of this animal weighs over 330. So if you find an animal of this species that weighs 330 pounds, you could safely say that that is a very large animal, even among this, this certain animal, whatever it is. If it's bear, you say, wow, that's a big bear, if it's bigger than 330 pounds. Okay. All right, so that is how you look up the numbers in the normal distribution table. I believe it's the last question, number 28. Make up 3 data sets, A, B, C. I will almost certainly ask you to come up with data sets that satisfy certain conditions. I want each of these, A, B, and C, to have 5 numbers each. Okay, so A will have 5 numbers. B will also have 5 numbers. And C will also have 5 numbers. All right, that's this one. And then A and B have the same standard deviation, but different mean. Okay, standard deviation should be the same, but mean different, right? So let's say my favorite, easy to manipulate and gives me enough space to move things back and forth. Let A be, 10, 20, 30, 40, and 50. It doesn't have to be. These are just examples, okay? You can do 100, 200, 300, 400, 500. Or if you like, you can do 1, 2, 3, 4, 5, or 70, 80, 90, 3,000, and 4 million if you like. It'll be hard to come up with the second part. If you want to have the same standard deviation, that basically means the interval between these is not going to be different from this. Okay, notice here, these are only 10 apart, all 10 apart from each other. So I can do 60, 70, 80, 90, 100. And you can see that the standard deviation will be exactly the same because they are exactly spread apart exactly in the same, with the same distance from each other. All right, so A and B will have the same standard deviation. You can calculate it if you like, but the different mean, because here the mean is 30, here the mean is 80. Now, how do I know? Because if you add up these numbers, it's 150, and divide that by 5, and you will get 30. And for the second one, if you add up all of these, that will add up to 400, and 400 divided by 5 is 80. All right, part C. I want A and C to have the same mean, okay? But the standard deviation of C should be smaller than of A. So let's just use 30 as the middle value. And instead of having them 2 apart from each other, how about 28, 29, 30, 31, 32? These are really crowded with each other, and the standard deviation will be smaller, exactly how I want it, right? But the mean is still the same because the middle number is the same, and well, that would be the median. But if you add up all these numbers, you still get 150. And if you divide 150 by 5, you get 30. All right, so here the mean is 30, right? Remember, A and C have the same mean, they do, and the standard deviation of C is much smaller than the standard deviation of A. Okay, as I said, this picture will be given to you, and I believe I will also be providing this. We didn't have to use this detailed table, and if this is not essential or required, I may not provide this. But anyway, you will have all the necessary tools, like one of these standard normal curve distribution table along with your test. And so I believe this is it. Yeah, so it was a long practice test, right? And I'm trying to provide you with as much information and explanation as possible. My suggestion is, if you don't have a good understanding of a particular topic, let's say, conditional probability, or, the normal distribution, or, the total interest, paid or something, just go to that specific problem and then look at that part of the video, all right? And I hope you understand all those, interesting and sometimes challenging topics, and I hope you do well. Just learn these 3 chapters, go over the practice test repeatedly if necessary, right? And I hope you'll be prepared to take your test and do well. Okay, so with that, I will say see you later, and let me know if you have any concerns or questions. All right, take care.